All right, today we're going to talk about enlarging and reducing. Again, remember, as you're watching the video, feel free to pause as you need to make sure you get all the notes. And again, feel free to rewind and go back and look at a problem again if you need to. So please remember to do that as we begin here. So to get started, we have this picture here, and it says, what would happen to the figure in the photo if the width was increased while the height remained the same? Okay, so the width is going to stretch it left or right. Well, if we do that, it's going to stretch it horizontally and become distorted. Okay, so it's going to make the dog look fatter, basically. This is kind of similar to on your TV, if you ever switch from a 4:3 aspect ratio on your TV and you switch it to a 16:9 aspect ratio, it's going to stretch the picture horizontally. So what would happen is the picture would look like this. Okay, so we went from the picture on the left to the picture on the right. That's what would happen if we stretched it, if we increased the width and stretched it horizontally. Now it says what would happen to the figure in the original photo. So if you remember, the original is the one on the left here, it's the 4:6. If the height was increased while the width remained the same. Well, what would happen there is it would stretch it vertically and it'd become distorted. So it would make the dog look taller than what it actually is. So if we go on to the next slide here, it would end up looking like this. Okay, we'd go from the one on the left to the one on the right. If we increased the length and not the width, it would stretch it vertically. Okay, so moving on. We have this table here, and this was the height of 6 and the width of 4. That was the original dimensions of our photograph. So we're going to figure out the missing widths there. So again, the method that will always work here is if I take the height and the width and I make a ratio. Okay, so I'm going to do height over width. Well, I know my height is 6. I know my width is 4. In the second one there, we know the height is 3. But we don't know what the width is. So remember, what you do is cross multiply here. If I take 6 times x, I'm going to get 6x. If I take 4 times 3, I'm going to get 12. And then to solve for x, I just divide by the 6 on both sides. Over here, the 6's cancel. I get x equals 12 divided by 6 is 2. So for this one, the width would be 2. Okay? Now for the second one that we don't know, the one that has the height of 1.5, okay, same thing. I'm still going to use the 6 over 4. And I could use the 3 over 2, but I'm going to choose to use the 6 over 4 because that's the one that was given to me. So I know that that one is true. Okay? So same thing here. If I take 6 times x, I'm going to get 6x. If I take 4 times 1.5, I will get 6. Divide by 6 on both sides. Again, your 6's cancel there. 6 over 6 here is 1. Okay, so x equals 1. So if the height is 1.5, the width is going to be 1. Okay, and then the last one, again, I'm going to use 6 over 4. That's the one I know is true. And I know the height of this one is 9. And I'm looking for the width again. Again, 6 times x is 6x. 4 times 9 is 36. So I need to divide by both sides by 6 here. And I get x equals 6. So now I know that the width of the one with the height of 9 has to be 6. All right, moving on here. Looking at some examples here. Same example we just talked about with the picture of the dog. What you can look at here on this one is they took and they did the width over height, which is perfectly fine. We could have done the same thing when we figured them out. We just would have had to make sure we filled um, the height in the correct spot when we put the unknown one in there. So as you can see, 4 over 6 will reduce to 2 over 3. Now where that becomes useful is when we move on to this next slide here, and we look at the last column here, and look at the width, we see that it's 2/3 h. All right, so what that means is that if I take okay, so the width equals 2/3 h. What that means is if I take 2/3 times my height, that's going to give me my width. So if we try that here with one we know, the 6 and the 4, so if I take 2/3 times 6, that should equal 4. Sorry, that 4 is a little sloppy there. Okay, so if we go to the calculator here and try that, now first thing, whenever I type a fraction into this calculator, I'm going to put it in parentheses. So I'm going to do 2 parentheses 2 divided by 3. And then I'm just going to put the 6 in parentheses as well because we're multiplying. Now when I hit enter, I get the 4. Okay, I could do the same thing with the 3. So if I did 2/3 and I put the 3 in there, okay, we already know from doing this table already that the answer should be 2, but let's just go ahead and try it here. So again, parentheses 2/3 times 3, there's my 2. Okay, it also works with the 1.5. If I take 2/3 times the 1.5, again, we already know that from doing this already that we should get 1. So let's punch it in and try it, and sure enough, we get 1 for an answer. So when you can figure that out, that's another way you can find missing values in the table. But again, setting up the proportion like we did before, that will always work for you. Okay, on the next slide here, it just shows you some other ways that you could do that. So if you want to take time to go ahead and look at that, you can. I'm not going to spend any time talking about it. Going on to the work time here. So we have an original photo that's 3 centimeters or the height is 3 centimeters and the width is 5 centimeters. So we have this table we need to fill out. So again, I've got height and width here, so I'm just going to set it up height over width. If you wanted to set it up width over height, you could do that as well. It's just going to flip all your numbers around. Okay, so I know my original height there is 3, and the original width is 5. So if I want to figure out the width for one that's 1.8 centimeters high, I'm going to put the 1.8 on top because that's where my height is, and I'm going to look for x. So again, cross multiply here. 3 times x is 3x. 5 times 1.8 is going to equal 9. So divide by 3, and I get x equals 3. So when my height is 1.8, my width will be 3 centimeters. All right, the next one here. This time we know the width, but we don't know the height. So same thing, I've got my height on top, my width on the bottom. So I'm going to use my 3 over 5 again. But now this time, I'm given the width, so I have to make sure I put that 4 on the bottom one here. And my unknown is the height, which is on top. So same thing as we did before here. 5 times x is 5x. 3 times 4 is 12. Divide by 5. And we get x equals 2.4. So when the width is 4, the height will be 2.4. The next one here, we're given the height again. So again, I'm going to use the 3 over 5. And they give me that the height is 9. And I don't know my width. That's my unknown. So again, here I'm going to cross multiply. 3 times x is 3x. 5 times 9 is 45. And I have to divide by 3 here on both sides. 45 divided by 3 ends up being 15. So I know that when my height is 9, my width is 15. Okay, the last one here, again, this is one where we know, I'm still going to use the 3 over 5, but again, this time we know the width. So I have to make sure I put that 10 with my width. My width is on the bottom, so I put that on the bottom, my unknown's on top. 5 times x is 5x, 3 times 10 is 30. Now I have to divide by 5 to solve for x. 30 divided by 5 is 6. So I know that when my width is 10, my height is going to be 6. Okay, make sure you get all those. Take the time to check. All right, in problem number 2 here, it says Jamal has a photograph that measures 5 inches by 7 inches. He wants to enlarge the photo and put it into a frame with no space left over. Which of the frames below should he use? Okay, there's 2 ways to approach this problem. One way would be to write the fraction here. So I've got 20 over 25 because my original photo is 5 by 7. So if 20 over 25 will reduce to 5 by 7, okay, then I know that this one would work. Well, the problem here is 5 goes into 20 4 times, 5 goes into 25 5 times. This reduces to 4/5, not 5 over 7. Okay? The other way I could look at this is set up a proportion and see if it's true. So if I took 20 over 25 and 5 over 7, I need to see if, when I cross multiply, if 20 times 7 equals 25 times 5. So if we check that, 20 times 7 equals 140. And 25 times 5 equals 125. So they don't come out equal. So A does not work. So I would not circle A. Okay? However, if I look at problem B, okay, 15 over 21, if I reduce 15 over 21, I know that 3 goes into 15 5 times, and 3 goes into 21 7 times. So B would work. Again, if you're not good at reducing fractions, you could set up the 15 over 21 and the 5 over 7 and do your cross multiplication here and see if 21 times 7, or 21 times 5, I'm sorry, is equal to 15 times 7. In that case, they will be. In C, so if you look at C, you can see that 10/14 will reduce to 5/7. And if you look at D, you can see that it's not going to work.